Hi, I'm Lily Pearce, and this is my project. Think before you drink. That was weird. Okay, so my project is I am trying to find the most effective way to purify water. And so I came up with my idea because, well, I really just came up with the idea in the first place because I wanted to help people, and I wanted my idea to spread so I could help others if my hypothesis worked. And by the way, speaking of that, my hypothesis is that the method of evaporation, which we have the method of boiling, iodine tablets, evaporation, and life straw. Evaporation is where we put like some sort of tarp over a pot, and then a sort of container in the pot, and a rock over the container on the tarp. Here we used saran wrap. Sorry. Here we used saran wrap and covered it with the rock on top and water in there, so it would, yeah. I'll go into more detail into that later. But so I hypothesis that the method of evaporation would work the best because this is where I'm going deep into it. Because so you have the tarp there and it's boiling the water, turning it into a gas. Well, the tarp is collecting the gas, creating it back into water, and the solids and the molecules of the bacteria they cannot connect or cling to the molecules of the gas because the gas is not a solid. Even though water is technically not a solid, gas is less of a solid. Water is technically solid. But yeah, and so if they couldn't cling to the molecules of the gas, then when they became when the molecules of the gas became water again on the tarp, it became cleaner water because there were less germs. And so we have this here, and it was about this high up to water, and then we didn't get much of it filled, but enough to measure it. And so the rock was like, let's say the pot was this was in the center. The rock was right here because this is the point of weight for the water to drip down to on the top. And that is why I think that it would work the best because it has the best method of cleaning. So we used snow water, tap water, lake water, and pond water. Woo! And we were testing it by total dissolved solids or parts per million, TDS or ppm. And so here is the, it's really small, but here is the chart of TDS. So 0 is absolutely ideal drinking water. And 50 is like carbon filter is sort of like it's good enough. 100 is like hard water. I don't really know what that means. I didn't have too much time to research. For 200 through 300, it's marginally acceptable or average tap water. 400 is high mineral or high tap or mineral springs water. And 500 is contaminated water. You have the chart bigger here, but you probably can't see it. So here we have the data. Cameraman, can you please zoom in on the data? Okay. Okay. So here we started melted snow. It started at 24 TDS parts per ppm, parts per million. The boiling, when we boiled it, it moved up to 31 ppm. Can I just abbreviate like that? Thank you. And then for evaporation, it went down to 15 ppm. Boiling, sorry, I forgot to say explosions. Boiling, the explanation is because you're letting the water, when it becomes a gas, go away, and you don't have anything catching it, so you have the same amount of solids and bacteria, maybe a little bit less, but way less water. And I already explained evaporation. For the iodine tablets, they're meant to take out bacteria and not exactly solids. Plus, you're actually putting a solid into the water, making it have more solids. And for the light straw filtration, we had to prime it, and that's like you're kind of like blowing out through it. And so yeah, I think some of it was left over, like maybe spit or something, but we're not exactly sure why it went up. And for the Noblesville tap water, which is average tap water, I started at 348, which is average tap water. So yeah, and for boiling, it went up to 210. Same explanation for all of these, besides the last one on iodine tablets. For the evaporation, it went down to 19. For the tap water boiling, it went up to 414 ppm. And for evaporation, it went up to 16 ppm. And for the iodine tablets, it went up to 362 ppm. And then for the light straw, sorry, I have the hiccups. For the light straw filtration, it went up to 370 ppm. Most of these went up, one went down. For the Morris Lake water, which was what I was reading for you, I'm so sorry. It started at 162. Then for boiling, it went up to 210. For evaporation, it went up to 19, and this is all in ppm, parts per million. For the iodine tablets, it went up to 162 ppm. And for the light straw, it went up to 219 ppm. And then for the retention pond water, which is this, and really gross, and you can actually see the solids, it was 273, which is actually low ppm. Actually less than the tap water. But I wouldn't advise drinking it, even though it is less. For the boiling, it was 502. Again, same explanation. For the evaporation, it went down to 9, which was actually really surprising because it had more solids than any other one, and yet it went down to less solids. But we do have a couple of explanations for that, and that's because I think we set our timer late, and then we had more time, so we collected more water and had more time to evaporate it. And then for the iodine tablets, it stayed at 273. Again, the time method, and I think it cleared all the bacteria, which could have been counted as a solid. And so then the solid of the iodine tablets were then put into the water, making it the same. And then for the live straw, it went up to 300. And so my conclusion is that the evaporation method did work the best, again, because of the explanation that I had given to you earlier. So thank you for taking your time, and yeah. Oh, by the way, sorry. If I could change anything, I wouldn't change anything, but I would add something afterwards. I would add maybe different water sources and I would add different methods, but that's more of an after thing, not a changing thing. So thank you for letting me into regionals.